About 4 months ago, I built this greenhouse in my garden, which, as you can see, now houses well-growing plants. I got cucumbers, strawberries, sugar melon, watermelon, tomatoes and bell peppers, of which surprisingly not one died yet. But that does not mean that everything goes perfectly, which you can easily figure out if we look at certain leaves or this stem. The problem is a fungus, which was caused by high humidity and could have been avoided if I opened the window more often. But on the positive side, this problem planted the idea of an automated greenhouse inside my head. This system should measure the temperature, humidity and soil moisture inside the greenhouse, send this data through a LoRa wireless connection to a gateway in my apartment 300 meters away, which then uploads it to the Internet of Things websites, where I can check on it everywhere in the world. And as a bonus, the system should also be able to use motors in order to not only open the window to control the temperature and humidity, but also to water the plants if the soil moisture is too low. And of course, this automated greenhouse should get powered through the sun, and thus also requires a solar power system. And in this first part of this 2-part video series, I will show you how I built the greenhouse, how I wired up the power and sensor system, and what kind of programming is necessary in order to get all the required sensor data into the internet. Let's get started. This video is sponsored by JLC PCB, where you can now buy 5 pieces of 4-layer PCBs for a price of only $5. So why not upload your Gerber files today in order to experience their 24-hour fast production time, super quick delivery and excellent quality PCBs. To start off this project, I searched for a big yet affordable greenhouse on the internet. And I found this one with measurements of 190 by 380 cm. As soon as I received it, I opened up the package which contained the metal foundation and laid it onto my lawn to determine a suitable spot. Then I cut the grass, marked the greenhouse square with a spade and started breaking up the grass, and afterwards removed most of it. While doing so, I also had the unique experience of removing a dead tree stump, which I will hopefully never have to do again in my life. But anyway, as soon as that was done, I distributed the soil in my square a bit more evenly and continued by screwing together the metal foundation, which I then moved into position. After I was certain that the foundation was level, by obviously utilizing a spirit level, I opened up the remaining packages, which contained the main parts of the greenhouse. And according to the given manual, we then connected all aluminum beams with one another through the help of the included connector pieces and screws. Now this part sounds like it was simple to do. But in reality, it took quite a while to find the correct aluminum parts and connectors, since the manual was not always that easy to follow. But nevertheless, after a few hours we completed the metal construction on the lawn, before we moved it all over to the foundation, to which we then secured it with more connectors and screws. At this point, all that was left to do was to add the plastic windows, which had to get secured in place with dozens of clips. And just like that, the greenhouse itself was successfully built. Now at this point, I do not want to bore you with plant growing tutorials. So let's just say that suddenly lots of plants appeared in my greenhouse. And let's instead continue with the electronics. For the power electronics, we need a 12-volt lead-acid battery, a solar panel and a solar charge controller. And luckily for me, I had those 3 components laying around from previous projects. To be specific, I got this 12 volts 44 amp hour car battery, which is a bit of an overkill considering that the sensor system will ultimately only draw around 24 milliamps, but the big capacity will come in handy when later trying to power motors. Then I got this 10 watts 12 volt solar panel, which in combination with this generic solar charge controller will charge up the battery with a current of up to 0.56 amps. To test this, I wired up the power electronic system in my garden according to this wiring diagram. Sadly though, the sun didn't feel like working with me that day. But trust me when I say that later when the sun was shining, the battery was charging without any problems. So next, I ordered myself this wooden chest from the internet, into which all the electronics will fit later on. Before putting them in there though, I added a layer of wood glaze to the chest in order to protect it better from the elements. Next, I also created 2 small wood blocks and 1 big square of plywood with the help of my jigsaw. I added the 2 wood blocks on top of the chest lids with screws and then mounted the big plywood square on top of it all at an angle. And as you would have guessed at this point, this is the roof of my electronics housing, which means I also had to add a bit of roofing paper. So, with the housing being completed, I got myself lots of this silicone wire with 2, 3 and 5 conductors inside, which is even suited to be mounted inside a sauna. What I did next was adding the solar panel to the roof with velcro tape, to which I then also secured 1 silicone wire through the help of wire pedestals and zip ties. I then soldered this wire directly to the solar panel before I positioned the chest enclosure in front of the greenhouse. There I then drilled 4 more additional holes into the chest, of which I immediately used 1 in order to guide the solar panel wires through. Inside the chest, I wired up the solar charge controller to the battery and solar panel like I described it before. And just like that, the power electronics part was done. And it was time to move on to the automation part, starting with this PCB I got from the internet. As you can see, it features an Arduino microcontroller as well as an RFM95 LoRa transceiver. Besides this board, we will also need capacitive soil moisture sensors, of which I'll be using 2, 1 on each side of the greenhouse, as well as such a BME 280 temperature and humidity sensor, and also a LoRa gateway like this LG021, about which you can also learn more in my LoRa video. The general working principle pretty much stays the same like I described it in the beginning. But let me add that the Arduino will send out the data every 60 seconds and we will be using LoRaWAN. So what I did first was hooking up all of the sensors to the LoRa boards for a first test run, according to this schematic, which will pretty much not change later on. You might also have noticed that I added an additional 5V regulator on the power inputs, which was definitely mandatory to add because the boards apparently cannot handle 12 volts. But anyway, the soil moisture sensor outputs an analog voltage from 0 to 3 volts depending on how moist the earth around it is. And the BME 280 sensor uses an I2C interface to send over its temperature and humidity data, which means we could use its datasheet to write proper I2C codes. But then again, there also exists a simpler to use Arduino library for it. With those information in mind, I firstly created a simple example code that outputs all of the sensor data through the serial monitor. And after using an FTDI breakout board hooked up to the serial interface of the LoRa boards and uploading the codes, it seems like everything works just fine. That was the easy part though, because now it was time to establish the LoRaWAN connection, for which I not only had to sign up on the Things network sites and edit the settings of the LoRa gateway, but I also had to use some rather complicated codes. However, this process was surprisingly simple to do, because the gateway manual describes in detail how to set everything up. Before uploading though, I had to connect two of the RFM95 board pins to two pins of the Arduino, because the utilized LoRa WAN library requires them. And after uploading the final codes to the Arduino LoRa boards, we can see on the Things network side that the data gets uploaded successfully in hex, which converted into ASCII turns out to be our measured temperature, humidity and analog values for the soil moisture sensors. Awesome! That means it was time for me to design a small housing for the BME 280 sensor and 3D print it before I once again headed into my garden. There I soldered the wires to the two soil moisture sensors as well as the BME 280 sensor, and then waterproofed the soil sensors with a layer of nail polish. Afterwards I secured the BME 280 sensor with its wire inside the greenhouse to the wall with wire pedestals and zip ties, and pushed the soil sensors into, well, the earth. Last but not least, I drilled 3 holes into the foundation of the greenhouse, through which I then guided all the wires, which ultimately got soldered to the LoRa boards inside the chests. And as soon as the power wiring was also done, the first part of this project was basically complete. And if we once again check the Things network site, you can see that everything still works fine. I hope you enjoyed this video. If so, don't forget to like, share, subscribe and hit the notification bell. Stay creative and I will see you next time!